All right, folks, welcome back. This is chapter 1-3, and this is recording number 1. Okay, so I always like to look back at the table of contents just to see where we are here. Okay, we're in the introductory chapter, the nature of probability and statistics. We've already talked about the difference between descriptive and inferential statistics. We've talked about the different kinds of variables and the types of data. And now we're going to talk about data collection and sampling techniques. Now this is very important. Now we're getting into what's really the important stuff. Now the reason it's important is because if you don't do your sampling properly, your results are going to be either wrong or even worse, they're going to be misleading, okay? It's bad enough to be wrong, but if you are also misleading, bad things can happen. You think that the vaccine works and it really doesn't work, as an example, okay? All right. So how do we do this? How do we avoid these problems, and how do we do our best to make sure that we are gathering data the right way? Let me mention one more time that the reason we're talking about this is because the population is too large for us to do a census. Remember, a census is where we look at everybody that's in the population. The population is too big, so we do a sample, and we just hope that we are doing the sampling correctly so that the sample appropriately and accurately represents the entire population. Okay, I hope that makes sense to you. Okay, so this first paragraph talks about that, about how, hey, we have all these examples of where it's important to be able to do this. And again, these examples may not be of interest to you, but find your own examples, okay? But this last sentence here, I think, is very important. These examples illustrate a few situations where collecting data will help people make better decisions on courses of action. Keep in mind that ultimately that's what we're trying to do with statistics. We're trying to help us make the best decisions that we can. Going back to my example of the vaccine, should we or should we not approve this vaccine? That's a decision that the Federal Drug Administration has to make. So they make that decision. Well, then the doctor has to make a decision. The prescribing doctor has to decide, well, there's risks involved with this vaccine. Should I or should I not recommend that the person take the vaccine? There's never any good answers. I mean, it's not like, there's never any risks. There's always risks to everything that you do. So you try to make the best possible decision that you can, okay? So one of the important things that we do in statistics, when we're studying statistics, is we try to figure out, how do we gather our data? How do we collect the data? Okay, so there's all these different ways of doing it. We're going to spend just a little bit of time on this. It's just one section talking about it. There's entire books written about this. It is a very complex area. This will just give you a total overview, and then we're going to ignore it from now on. When we get into the hypothesis testing and so forth and so on, we're going to just say, well, here's the data. We're not going to worry about how did we gather it, is it valid data or not. We're going to just assume that everything was done correctly. But let's just spend a little bit of time on this, okay? So here he talks about how you can collect the data in a variety of ways. You can do it by surveys, okay? Now, again, surveys can be done in a variety of ways. Different ways that you can do a survey. Do it by telephone, you can do it by a mailed questionnaire, and the personal interview. Now, you probably have been exposed to this. Somebody has probably called you on the phone or on the internet, has popped up, and they say, hey, we're doing a survey. Would you answer some questions? Okay. So there's advantages to the telephone. Here's one about the mailed questionnaire. I'm sure you've gotten these. If you ever go on a website, like for the bank, at the end, they might say something like, hey, would you answer a few questions for us? That's an example of a survey. So again, I don't think it's worth your time for me to read this to you, but please read it and get the idea here, okay? All right? Okay, so that's a survey. Another way is you can survey records, or you can have direct observation of situations, okay? All right? So, doing these surveys is an art to it, okay? One of the problems with surveys is that it's very difficult to make sure that you're getting an unbiased sample. Remember, unbiased or bias means that the sample does not properly reflect the population. So just as an example, okay, one of the things that I'm seeing nowadays on the internet is they'll say, do you think that President Trump is doing a good job? Do you think President Trump is doing a bad job? Okay. Are those really unbiased? Probably not, because the people that are going to answer those questions are people that are very, very partisan. They're really into it. They have really strong opinions. Okay. It's not a random sample of the entire population. That's an example of what I'm referring to. Okay, so we can also we can survey records, we can observe situation, you can watch people do things, okay? You can look at records, go to the hospital, look at medical records, that sort of thing, okay? Here's the key thing about samples. You want it to be unbiased. When we say it's unbiased, what we mean is that each subject in the population was equally likely to be chosen, to be selected. Okay, now let's think about that for 1 second. If they're equally likely, now maybe the likelihood of an individual being selected is very, 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 very small, right? Like, let's just say for the sake of this discussion, there's like 80,000 students at Riverside Community College District. So the likelihood of, if you're picking 100 people, the likelihood of somebody being picked is very, very small. But somebody's going to be picked. And as long as the 100 people that you pick, as long as each one of them was equally likely to be picked, well, then that's probably an okay sample, okay? Okay, so the first thing we want to talk about is random sampling. There's four basic methods of doing it. There's random samples, systematic, stratified, and cluster. So the random sampling, all members of the population have an equal chance of being selected. And it's some sort of a chance method. You can put all the names in a bowl, you mix up the bowl, you reach in there, you pull out a name. Okay, so everybody has an equal chance of being selected. But it's hard to do that, right? I mean, let's say we're going to do a sample of the students, and we're going to pick 1,000 students as a sample. I mean, do you want to put 1,000 names in a bowl? It doesn't make any sense, right? So we try to have some other ways of doing it. A very common way of doing it is using random numbers. Okay, so the concept of a random number is a little bit maybe beyond the scope of this text, but the concept is very simple, that you have no way of predicting what the next number is going to be. It's random, okay? So if it's random, and if we use the random number generator from a calculator or from a calculator or a computer or what have you, and if we assign these numbers that we pick to the population, then kind of by definition, everybody that we do ultimately pick was picked randomly. Does that kind of make sense? I mean, it's, if I line everybody up, I line up, 60,000 kids that are the students, and I say, okay, I'm going to pick randomly. I'm going to pick the first guy, then I'm going to pick the 8th guy, then I'm going to pick the 28th guy, then I'm going to pick the 545th guy. If I pick them randomly like that, then obviously by definition, I've picked a random sample. Okay, so in essence, that's what we're doing. Now, what the author is doing in this section of the book here is he's saying, well, you can do it with a computer, but before we had the computers do it, we use these tables. So for whatever reason, he's using these tables, and I'm easy. Let's talk about it here a little bit here. Okay, so we've got these tables are in the appendix, okay? And what we're trying to do is get a random sample. We want 15 subjects out of 85 subjects, okay? So you have 85 people that you're picking. So we number each of those persons, those 85 people. You give them a number. Now, this part doesn't have to be random because it's going to be random later on. So the first guy, you say, hey, everybody line up here, okay? So you're number 1, you're number 2, you're number 3, and so forth, all the way up to 85. Okay, then we have to pick a starting number. And so you just pick that just by closing your eyes and putting your finger on the table. So let's go to the table. It's right here. Okay, here's the table that's in your book. And in this particular case, what he said was, let's pick let me find that. We're going to just, in this example, hold on, don't go away. It's the 4th column, the 5th number. So the 4th column, 1, 2, 3, 4, 5. fourth column, fifth number. 1, 2, 3, 4, 5. So 9244. Have I got that right? I don't think I got it right. Hang on one second. Okay, so I think what he's saying is, if I read it, it's hard to bounce back and forth on these screens here, but he's saying it's the fourth column, 1, 2, 3, 4, and it's the fifth number down. So it's 1, 2, 3, 4, 5. So 88948. That's the number you pick. Okay, so that's it. That's the number we're going to start with. Then we're going to go down and we're going to pick numbers. Well, we don't need such big numbers, right? We want numbers between 1 and 85. So what we do is we go down and we grab these numbers. Where the heck am I here? Okay. You only need 2-digit numbers. You need between 1 and 85. We use the last 2 digits of each of those numbers. The first random number that we pick then is 48. Where's that at? That's right. Gosh, this is so hard to do on the screen. There it is. 48. What's the next one? 43. What's the next one? 44. What's the next one? 19. Now let's suppose you got a number that was bigger than 85. Let's say you were down here for some reason. You're down at 97. Well, what do? You ignore it. You just toss it out. You say, well, I don't want that one because I only have 85 people in my group, so I want from 0 to 85. So if it's bigger than 85, we ignore it. Okay, so now, everything, we're all human beings here. There's a typo in here. In your book, let's see if it is in the, okay, right. Yeah, in the printed book and in this electronic version, uh, you'll see what he has here. The numbers go 48, 43, 44, blah, blah, blah. Then he comes here is 58, okay, 58, then 24. Well, if you look at it, that's not correct. This is tedious. Okay, I'm going to count on you to do this on your own. I can't do it. If I was in front of a screen, I had my hands to point, I could do it, but I can't do it this way. This is where we start. So 48 is the first number. So he's got that right. The next number is 43. Look in your book and you'll see that I'm not lying to you. So 48, then 43, then 44, that's correct. Then 19, that's correct. Then 7, then 27, and then what's the next one? The next one is 57, 57. Then it's 24 and 68. But he doesn't have 57. In the book, he has 58. So it's a typographical error. So I'm pointing that out to you in case you're very conscientious and you're trying to, do everything, compare the book, trying to follow along in the book, and you saw that he had the wrong number, it would drive you crazy, right? So I'm just telling you that's a typographical error. Okay, so that's how you do it with the random sampling. So let me, I can only record 15 minutes at a time. So let me end this video right now, and then on the next video we'll get started on systematic sampling.